I'd like to talk about some work we've been doing. Really, it's part of a broader focus trying to understand inventories in Canada, what the regulatory policy implications are as we start to improve and dissect inventories, how we can make them better. And as part of that, that gets us into measurement technologies. And in particular, as you've heard from the intro, we're working with lately a technology from Bridger Photonics, which is really quite interesting on what it's allowing us to do. And so I'm going to walk you through some of that that we've been doing. This work has all been done with my co-author, research associate David Tyner, who's been with me for more than a decade now as part of our team. So maybe to try to set the stage a little bit, and it's really impossible to do justice to the breadth of literature that's out there, but in Canada anyway, we did some work with scientific aviation a few years ago. You can point to quite large discrepancies with inventories. ECCC using adjoint methods. So this is Doug Worthy and Felix Vogel and Elton Chan and others doing inverse analysis on stations over Western Canada. This is an EST in the fall. That emissions are nearly twice inventories. Really interesting work out of St. FX University using truck sensors. Actually, Liz O'Connell I saw on here, so she's the author of one of these older papers. Similar kinds of things, lots of people pointing to these discrepancies, and this is just in Canada, and of course, this is echoed in many other studies, but in a global sense, this study by Ben Humiel really points to this persistent gap that we just can't seem to close. And I know there have been some theories on why that is. I'm not sure I agree with them all, but in Canada anyway, this gap persists and it's a problem. On top of that, there's just, what an exciting community and exciting time to be doing this kind of stuff. Ben Luck, Dan Zimmerle, really interesting work unpacking the complexity of pneumatic emissions, fantastic insights recently on compressors and how the exhaust might contain more methane than we think and might be a more important source. David Lyon, I don't know if he's on today, this paper that was out recently that points to unlit flares in the Permian, and it kind of builds the methods they used a few years ago, that pointed at tanks just about everywhere they looked as big sources. Arvind Ravikumar got some neat work in Canada, trying to look at repeated OGI surveys. And, I think that kind of suggested repeated surveys were helpful, but maybe it was another hint that there are bigger sources out there than the fugitives we might have been chasing. Again, some of our own work with Aerodyne in Canada specific, there are sources like CHOPS, cold heavy oil production with sand, which are really quite a unique beast and have really quite profound impacts in the overall inventory. So we have this kind of knowledge of specific sources emerging and a deeper understanding, yet we still can't quite close the gap just yet. And we're still struggling with these bottom-up inventories that in Canada, maybe this is a bit of a self-plug here, but some other work we did recently, Canada federally is a difficult place to be a regulator, I think. I saw a couple of ECCC folks here. You set a federal standard, but ultimately it's up to the provinces to implement it, and then you get mired in these equivalency agreements. And the kind of point here is, well, we published an analysis on that. It's all predicated on some understanding of the inventory. And so all this comes back to, if we don't have a good understanding of the inventory or don't have a way to check the inventory, or maybe it's time we start rethinking how we create inventories. And that's really the setting for this talk. So just to finish this kind of intro, there's many key challenges. What a great time to be those who are grad students in this kind of research community. I'm certainly not going to answer all of these today, but this just scratches the surface of what we need to be working on. What's it going to take to make a better inventory? How do we use new technologies to do that? If our inventories are wrong, and we're pretty consistently finding out that's true, what are the implications for the regulations we have that are based on those inventories? Do we even have the distribution of sources correct? And then, I think we're starting to talk about targets beyond 45%. It's unclear if we're even going to achieve those. And, what are the opportunities? So with that, Among other projects in a lab in our team, what I'll focus the presentation today on is work we've been doing trialing Bridger Photonics, kind of exciting new LiDAR, gas mapping LiDAR is what they call it, technology. And for those of you who don't know, it's a LiDAR-based measurement. It was developed through the RPE program. So one of the success stories out of that, for that program that produced a number of really exciting innovations. And here's a picture of the plane that's used, just a regular old Cessna type plane. The laser system is underneath the belly. There's some additional computer gear in the back, but a relatively small system. It shoots kind of a spiral pattern that makes ellipsis on the ground as you fly. You get a kind of forward measurement and a backward measurement in the perfect world as you fly over a site. That gives you some 3D information about heights of plumes. The measurement swath at standard kind of altitude that we fly, or they fly for us, and sensor field of view is about 128 meters in the ground. And you get resolution. Here's an actual image with plume overlay on an actual site. The resolution of the plume is about 2 meters. So really quite impressive for being able to look within sites. And so of course they detect sources, but then they quantify. And the first thing we wanted to try to figure out, we were lucky enough to get involved in this study in British Columbia, Canada. A small study initially trying to test out this technology and basically was nicely open-ended in a way to see how far we could take it and compare a 2019 survey with 2018 optical gas imaging at mostly the same sites. So there sites in Canada are very difficult to count. There are 167 locations on the ground. In terms of reporting entities, because sometimes there's multiple on a site, it's north of 300. And the work that we did was, of course, to trial Bridger's GML technology, but also what now everybody knows, but Bridger had no knowledge of this at the time. The contract with Bridger originally was with the BC government directly, and then we were separately going to work with the BC government to do the analysis. So unbeknownst to almost anyone, we put a team on the ground, and officially we were just going to go out and put up wind sensors, because with any of these types of technologies, uncertainty in wind is basically a direct multiplier in uncertainty of the quantification. But of course, we then also went out and released methane from within the same facilities that Bridger was surveying to get this fully blinded test with controlled releases. And why we want to do this, of course, we want to understand what do they see and what don't they see under what conditions, and how does that vary? And that's necessary information if you're going to take this next step and think about using that information to try to build inventories. And of course, another dimension to this was then comparing with OGI surveys that ended up taking on a life of its own. So this first bit of work was just published about 2 months ago now in Remote Sensing of Environment. And for that paper anyway, we ended up with a team of 8 people. All this had to come together in about 2 weeks to pull this off. So I don't think many of them are online today, but I have to give credit to my team at the Energy Emissions Research Lab, who just moved a mountain to make this possible. And so chasing a plane, because this had to be done blinded, so we had limited cooperation. We caught up to them at 48 unique sites, 5 flight areas, 65 wind measurements, 29 fully blinded releases. And this gives us this true objective test of what Bridger can find when they don't know they're being tested. And so just to show you a little bit more of that paper before I switch over, the pink in this image is image of their laser return signal, which from Bridger. So we look at that to make sure that our releases are within their swath and that they had the potential to detect it. In this case, the little flag is our wind sensor, the little stars at controlled release. Bridger correctly finds that, tags it as number 45 in their algorithms. Turns out there's another source adjacent, on the actual facility at number 44. This kind of gives you an idea of the resolution and the ability to pick out multiple sources. It's not perfect, of course. Here's one we can confirm from the white lines. Those are indications of the airplane flight path on multiple passes. So they passed directly overhead, directly over, laser swath is good, but they missed our release. And then always in field work like this, there's a few edge cases, literally. Because we didn't always have permission to be on facilities, we sometimes had to be on the edge. And so here's one we'll just call a null release because it wasn't a really fair test for Bridger. And then there's a couple other cases where we released, but it turns out there was a big source on site, etc. Long story short, if you kind of plot that data, you can get this indication, and this is what's in that paper in remote sensing environment, of blues are things they found, red are things they missed, and it works out to be a function of wind speed. You might argue correctly that this data is kind of sparse. I think to that we have to say, well, you have to recognize the difficulty in pulling this off in a blinded fashion. However, if we overlay the actual detects from actual sources across the survey, it more or less aligns. And what I can now tell you is we haven't quite stopped here. This isn't published anywhere. We've done a little bit more of this, and basically as we continue to add data to this in the same blinded way, that function appears quite robust. And so that's very powerful. That means if we have knowledge of the wind speed, we can understand what we have the potential to detect and what we're missing or what we may be missing. And of course, not to be lost here is the units on this axis. This is kilograms an hour. And this is at wind speed at 3 meter elevation. And so, and the positioning of the points is indicating what the wind speeds were during the time of survey. And so we're getting down in the right conditions to kind of 1 kilogram per hour or better. And generally within this 1 to 3 kilogram per hour sensitivity range. So hundreds of times more sensitive than satellites. And really more sensitive than anything else I'm aware of that can do this at this scale. Of course, detection sensitivity is one thing. I don't have time to go into this in detail, and there's more than I'm showing you now, but we've, of course, looked at the uncertainties. What's in this paper is quantification uncertainties for these controlled releases. So these figures give you probability density functions of the quantification error, or relative quantification error, depending on whether or not we have a wind sensor on site or whether that has to be done with interpolated wind. And because wind speed is such a driver of quantification uncertainty, at the sensitivity limit, 1 sigma error is in the order of 30% to maybe 70%, depending on what kind of quality of wind data you have available for a single pass. And then if you get to do multiple passes, there is some averaging there to be had. And so really quite intriguing for what's possible. To be fair, this is at their sensitivity limit, where if we had stronger signals away from the sensitivity limit, which is something else that's ongoing, then these are likely to improve at least slightly. So that's kind of the background on Bridger. Happy to talk more about that. What I want to kind of turn the latter part of this short talk is what we've done with that since. And so this is really this paper that was just out this week, kind of a long time coming in the public release part of that, but really exciting work that's gone on over the past kind of year and a half. So knowing the performance capabilities of Bridger, we set out to first do this broader survey of sites within the Montney region of BC, a really important natural gas production region in Western Canada. And more interesting is that these sites were part of an OGI survey 1 year prior, so we can do some comparisons 1 year displaced. We also, through excellent cooperation with the BC government and input from people like Don D'Souza and Marie Johnson especially, we had access to facility plot plans, high resolution aerial imagery we could use from Bridger, on-site equipment count data, so that we could attribute sources. And ultimately, We didn't honestly know we were going to be able to do this at the start, but it proved possible as it evolved. We were able to create a measurement-based inventory. And I think the value of this is not necessarily, the numbers or, the actual magnitudes for BC, which is very interesting in BC, but the bigger picture here is what are the real distributions of sources that we're seeing, and how do those source distributions differ from the inventories in Canada at least, and then what does that mean? So a little more about how this works. Here's a site from the survey. And Bridger continues to improve their technology, so it's making it a lot easier. But at the time of this, we had data separately for individual passes that we pieced together. So the plane will come through, and some of this is automated now, but at the time it was all manual. They'll make a pass on this flight path. So that's the actual flight path. They'll tag potential sources with their own individual ID numbers. Different things happen. Here's a source. They're not sure of the location, so it's one of these two, but they recognize it as the same source. There's a second pass to cover the site, and new numbers on sources that were potentially 9 and 10 are now 15 and 16 in the data. Anything with detected emissions, we come back on a second day. This is part of understanding persistence, another new set of numbers, etc. You put together the jumbled mess, and eventually through kind of reasoning, a lot of manual work at the time, and I think it's all very logical, but conservative choices. We're never averaging with a sensitivity limit. We're averaging with a 0 if it's a non-detect, etc. You end up with a coherent set of sources. Maybe the picture doesn't look that coherent because it's combining all plume images with all different wind directions, but that allows you to get a quantified set of sources you can start to look at across multiple sites. So we've seen these kinds of distributions many times before. In the British Columbia area, 28% of sites we flew had measurable sources above Bridger sensitivity limits. 10% of sources above 32 kilograms an hour. But if you look at the distribution shapes of these, the Gini coefficient, the measure of disproportionality, is right in the range, the middle of the range of a whole host of studies summarized by Daniel Zavala in a paper in Elementa a few years ago. Data that's not published, but I'll talk about this in a sec. We've started much larger scale, another 10x or 20x larger scale of survey in Saskatchewan. And somewhat comforting, even though the samples in BC are perhaps small, we're seeing the same kind of distribution shapes in other regions, which maybe we'll come back to. Bottom line though, like everywhere else, I mean, this has been said many times, most eloquently, I think it was an early paper, Adams and Arvin's, but these skewed distributions are really the killer for inventories. It's the few large sources that really drive things. So that's fine. That's all kind of been done before. But we want to dig deeper, see if we can use this, title of the talk, can we use this technology to build an inventory? Can we rethink how we create inventories, and what can we learn in the attempt? So this is the kind of satellite imagery of an actual site. We fly, and Bridger's actually improved this again. Some of this is unabated. For us, they snap an aerial photograph, which you can see is high resolution, but it's not geo-registered. And they will detect sources, which we can overlay, and you can see satellite data for anybody who works with this is always, a blessing and a pain. Here's source number 2 in empty space. But if we look closely, there's a building in the picture that's not in the satellite. So if we, with a polynomial mapping, geolocate this, put it on top, we can, now, okay, now I know that is coming from something physical on the ground. So that matches. But what's really exciting in this study, and I don't know that we could do this anywhere other than British Columbia, so really kudos again to the government there, is we were able to get facility plot plans for the vast majority of these facilities, which coupled with observations from our own team when we were on the ground, or the OGI crew the year prior, you can look and say, oh, that building number 1 isn't just a building, that is a dehydration unit, and building number 2 is a compressor building. And it becomes possible to attribute sources with a high degree of confidence. And so in this study, we were actually able to confidently attribute 95% of the sources, which were 87% emissions, to specific major equipment types. And first kind of major interesting finding is that 64, almost 2/3 of those sources and almost 80% of the emissions in that Bridger saw anyway, were 3 things: tanks, compressor buildings, and surprising to us anyway, especially at the time, unlit flares. So there's an example picture with the high resolution overlay, complete, et cetera, of a tank. Our median emission rate on tanks about 13, 14 kilograms an hour. There's a compressor building. We're seeing median rates of 8 kilograms an hour, which really didn't make a whole lot of sense to us at the time, but because if you look at the OGI survey where they were measuring rod packings, their median was far lower. In fact, the max they saw anywhere was 3 kilograms, and our median was 2.5 times that or more. But mention it again in a minute, but Dan Zimmerle's team has done some really nice work at gathering stations looking at combustion slip, and this really seems to be a contribution from that, although maybe perhaps a little higher than he saw in the States. And then of course, unlit flares, another key source. There are other sources beyond that. Here's some examples of an amine boiler, dehydrator, generator, cooler, but these are much less important than the big 3. So now we're measuring sources across many facilities at a time. We're attributing to specific source types. We can look at the distributions, but what about the comparison to the optical gas imaging? And so this was the other big surprise for us anyway in this study. So BC had commissioned a survey of many of these same sites in 2018, 1 year earlier than we were out. And the idea was to go detect sources with a OGI camera, where possible, quantify them with a high flow sampler, where they couldn't for access or other reasons, then at least visually estimate what it was. And importantly, they were looking for, tasked with looking at both fugitive and vented sources, although they weren't measuring pneumatics. Instead, they were documenting specific makes and manufacturers, which we'll get to in a second. And so 79% of their sources they actually measured, but that was only about 43% of the emissions. And 96% of what they see is less than 1 kilogram an hour, which if you remember that sensitivity limit I showed you, it's not even things that Bridger can see for the most part. Their biggest source in the ground survey was tanks, but 21 and 22 of those were visual estimates, something to keep in mind. So if I scrunch that data down and change the scale here, because I need to, I can then overlay what the airplane saw at the same subset of sites in the survey 1 year later. And to our honest surprise, we're seeing kind of 5 to 18 times more emissions overall, where all of the sources in blue were measured over 2 days. So 2 separate flights over 2 days. And, you know, 60% of what the plane sees, as I mentioned, and 80-ish% were from unlit flares, compressors, and tanks. And so I don't really have time to get into details, and there's more in the paper, but what we really think is going on is the OGI and the aerial surveys are finding it's different types and different magnitudes of sources at the same site. So they're not necessarily seeing the same things, but the obvious implication from this graph is what the airplane sees is potentially more important. But the two together are complementary. So to maybe illustrate that point, if we look at, this is in the paper, and so I'll just look at this quickly. On a site basis, if you look at what's being seen by the airplane here in blue, and you probably can't see this in the presentation, it's more just to highlight what to look for if anybody's interested in reading up later. Each letter tag is spelled out over here because there's fewer is the specific source that we've identified. If I overlay 1 year earlier what the ground crew saw, you can see there's just, I wouldn't make the comparison on any one site, but if you look at this in aggregate across all sites, there's little comparison on what's going on here. The difference isn't in reported emissions. Most of these sites don't meet reporting thresholds for venting, and when they do, it's the green dots. These green dots are in the month of the survey, of the Bridger survey. So that's really not what's going on here. And then if I draw in these lines that represent the sensitivity function, so obviously to make these plots clean, they've been ordered by wind speed at the time of measurement. But essentially that sensitivity function conveniently almost perfectly separates what the camera is seeing and what Bridger's seeing. So maybe these really are complementary. So there's more to talk about here, but just to try to wrap this up so we can get to questions, we took this in another step further. What if we take everything below that line in orange as a measure, as an aggregate measure of what, because it's on the same sites, of what Bridger can't see. So we're obviously deleting anything above that line before we do this, to which then we can add to things that the airplane can see and try to build an inventory. And so maybe skipping this table, but this is done on a site type basis, so we can appropriately scale that up if we're going to try to make an overall inventory estimate. And so we're combining the direct aerial measurements with just the portion of the ground survey data below that sensitivity limit. When you see 95% confidence intervals here, there's a whole Monte Carlo analysis behind the scenes where for each individual pass of Bridger on multiple passes and multiple flights, we'll draw from a distribution that we derived in the controlled release paper for an uncertainty on that pass. We'll propagate wind speed, everything else, so we can get as best air bars as possible on the Bridger measurement part of things. So in hopes of getting to the discussion, what does this mean? Well, there's the 2019 federal inventory for ECCC. And I don't, for anybody from ECCC here, the point here isn't to be critical necessarily of the inventory as an entity. It's a reflection of how it's created. It's a bottom-up inventory that, a lot of the numbers in there are based on measurements at a couple hundred sites only. And most of that is actually done in a neighboring province. So nevertheless, if we compare then our inventory estimate based on what Bridger saw, already it's that alone is above. To that, we can add the added contribution derived from the OGI survey for sites below the sensitivity. And then we can add a much more robust estimate of pneumatic emissions than are in the inventory, because neither the OGI survey nor Bridger are seeing those. And what's important about this gray bar, this is because the OGI crew looked at actual makes and manufacturers of the specific pneumatic equipment that was on those sites. This is arguably a much more robust estimate based on manufacturer specific information rather than assuming 1.2 controllers per well site, etc. We can put error bars on that represent, this is just the error in Bridger's quantification, where in theory, the error in the gray bar, whatever it is consistent somewhat across both inventories. And in doing so, there's a multiplier here of somewhere between 1.6 and 2.2 times. So this is brackets the range of the ECCC study of Doug Worthy and Ethan Chan and others at ECCC using adjoint methods, who suggested that oil and gas sector emissions in Western Canada were a straight 2x multiplier. So that's somewhat comforting, even if not good news. And one very important message is this is 2019. And really, this just means our baseline is probably a lot higher than we expected. New methane regulations started being phased in January 1, 2020. And so it'll be interesting to see what the impact of those regulations has been and how far we've come from here. So the hope is we've reduced this a lot, but I think it's healthy to know that we were starting from much more than we wanted to be starting from. I don't think any of that is the important part of this paper. I think what's interesting is this pie chart. And, you know, that's the rather audacious title of the paper itself. So indulge us perhaps, and we apologize, but this is the best we can figure from on-site measurements, combining cameras, plot plans, aerial imagery, all the attributions. This is where we think the methane is coming from in relative proportion across the whole inventory. And what's interesting is this is different than you might find in the federal inventory. Not surprisingly, but if your regulations are based on one set of assumptions and this is what's out there, then there's all kinds of interesting implications that come from here. You know, so tanks are almost a quarter of what we're seeing in BC. Compressors are also more important than we'd think in the inventory. Pneumatics actually at 20%, including pumps, are actually a smaller fraction in the US inventory. I think that's 35%, you know, so whether or not that's a direct map from BC to, you know, across the whole US, maybe not, but certainly is smaller than you might think. And then this unlit flare piece is a, well, at the time was a total wild card. Now that David Lyon and EDF and others published the results from the Permian, seeing lots of unlit flares, maybe this is something that we didn't expect to see. And maybe it's actually a good news thing, because this should be an easy fix. So to wrap up and hopefully get to any questions, honestly, the Bridger technology exceeded our initial expectations. We had no, I was gonna say we had no faith. That's not fair at all. We had no expectations that this was going to work. And that's why we did these blinded controlled releases kind of on our own initiative. We didn't want to be trying to use their data to build inventory if we didn't have some measure of it. But kudos to Bridger. They're getting down in the right conditions all the way down to about 0.6 kilograms an hour, but more generally between 1 and 3, depending on the wind speed. And they've made a number of improvements in the data processing since this. That's backed partly by some of this testing in Saskatchewan I shared. I think we've got a potential then to do measurement-based inventories. It's hard to imagine what might be possible, mostly because this is stuff we couldn't even dream of doing 3 years ago. And for Canada, at least, where we're phasing in regulations and trying to make real-time decisions about equivalency, there's a real opportunity here. And then more generally in the results, in British Columbia at least, we see tanks as kind of the #1 source, but we've seen that in other jurisdictions. But there's a lot of questions about that. The character of tank emissions is largely unknown. It's not well quantified, especially if you get to heavy oil sites. There can be, anecdotally, there can be extreme variability in the possibly both the methane concentration and the total flow rate. It's got implications for mitigation. So I'm not trying to propose these are necessarily easy solutions, but it starts by knowing what we need to focus on. Compressor exhaust seems to be a second important and largely hidden source, at least in Canada, but that's backed by the excellent work of Zimmerli and others. And I think this is going to be an important consideration for future gas certification if compressors are this big a source and they're not well captured by OGI. Pneumatics are possibly less important than other recent inventories, and maybe this just reflects early action towards air-driven systems in BC. And then unlit flares are this wild card, but we've seen some of the results in the Permian. And so last slide, perhaps. So what are we doing next? So maybe happy to share, this is the beginning. If you look at a map of Western Canada, kind of 5th largest oil production region in the world right now, and lots of gas, maybe the 2nd. This is a map of well sites, active well sites out west. This is a map of active facilities associated with those well sites, some of those being single well batteries. And so we're gearing up with Bridger, pooling together funding and backing from a whole variety of sources to pull this off, to attempt a survey of a little north of 8,000 sites across 4 provinces later this year. On top of that, with EDF, we will include parallel flights by scientific aviation in some select regions where there's some obvious advantages to overlapping those and leveraging them. And then there's some other parts of this that I won't get into details now, but hopefully we can talk about soon with specific components in BC and Saskatchewan. So I think the message here is we're really quite excited with the way technology is evolving and how we might use it for inventories and some of those bigger picture questions. So stay tuned. Thank you very much for the invitation to speak, and I look forward to the discussion.